This lesson is 2.4 and 4.9, day 1. We will be modeling polynomials, including quadratics. So first, we're going to start talking about quadratic equations in the different forms. So remember, we have vertex form, which is y equals a times x minus h squared plus k. And the vertex would be considered hk. And intercept form was y equals a times x minus p times x minus q, where p and q were the x-intercepts. We will be able to write quadratic equations given a point on the vertex, given a point on the x-intercepts, and also given 3 points. So first, let's look at this example. The graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. We want to write an equation of the parabola, and then if the performer lands in a net 90 feet from the cannon, what is the height of the net? So let's start by looking at an equation of the parabola. We're given the vertex is 50, 35, and another point on it is 0, 15. So of those 2 points, 50, 35 is h and k because they're the vertex, and 0, 15 is just an x value and a y value. So since I'm using the vertex, I'm going to use vertex form. So that was y equals a times x minus h squared plus k. And I'm going to plug in everything except a. So that means I'm actually plugging in the y, I'm plugging in the x, I'm plugging in the h, and the k. So that's going to be y is 15 equals, I'm going to leave a, x was 0 minus h was 50 plus k is 35. So I can solve this because I want to get a alone. So I'm actually going to move the 35 over. So now I have negative 20 equals a times 0 minus 50 is really negative 50. So if I do negative 50 squared, I get 2,500. And then if I divide both sides by that 2,500, we can get a fraction or a decimal. I actually kept it as the fraction here, but you might want to keep it as the decimal. I get negative 1 over 125. All right. So this is the a value. So to rewrite it, now when I rewrite it, I'm going to keep the letter y. I'm going to plug in a. I'm going to keep the letter x, but I'm going to replace the h and the k. So it's going to be x minus 50 squared plus 35. So that is the answer to part A, right? That is the equation of the parabola. Part B, the performer lands in a net 90 feet from the cannon. So they're talking about a horizontal distance of 90 feet. So for part B, we know x is 90. So I'm going to substitute that in. So 90 minus 50 squared plus 35. So that's going to be 40 squared, or 1,600, times the negative 1 over 125. So that's negative 12.8 plus the 35. So that means y is about 22.2 feet. All right, and if we look at the graph, that's 20, that's 25. It does look to be about 22.2 feet. So you're going to go ahead and try this one, pause it, and when you're ready, play, and you can see the answer. Alrighty, so we see that we have the equation of y equals negative 0.016, or that also would have been negative 10 over 625 times x minus 25 squared plus 30. And for part B, the performer lands in a net 60 feet away. The net's height was about 10.4 feet. The next time we're going to try, we have the x-intercepts and another point. So here, a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. So now I know that I have a point, xy, And then my two x-intercepts are 4 and 24. So P could equal 4 and Q could equal 24. It doesn't matter which one we call P and which one we call Q. So that means we're using, let's write it over here, y equals A times x minus P times x minus Q. So that's going to be 9.6 equals A times x was 0 minus 4. And then again 0 minus 24. So 9.6 equals A times negative 4 times negative 24, or 9.6 equals 96A. So when I divide both sides by 96, A is 0.1. So that means this equation is y equals 0.1 x minus 4 times x minus 24. Right? Final answer should still have the letters x and y in it, but we're replacing everything else. All right. What is the coldest temperature? So we know the coldest temperature would be at the minimum value, or the vertex should be somewhere around here. So I'm going to find the vertex of this equation. And if you recall, to find the vertex, we take the average of P and Q. So add them together, divide by 2. So 28 over 2 is 14. And now I'm going to take the 14 and put it back into the equation. So that's 14 minus 4 times 14 minus 24. So that's 0.1 times 10 times negative 10. So my overall answer is negative 10. So the coldest temperature is negative 10 degrees Celsius. All right, you go ahead and try the next one. Again, you can pause it, and then when you're ready, hit play to see the answer. All right, so my equation ends up being y equals 0.05 times x minus 6 times x minus 21. And for the coldest temperature, the x value of the vertex was 13.5. And when I substitute that back in, I get negative 2.8125. So that's about negative 2.8 degrees Celsius. Before we talk about making a quadratic with 3 points, we're going to talk about writing a cubic function given the x-intercept and a point. So just like we did with the two parabolas just here, right, the two x-intercepts and the point, now we're going to do 3 x-intercepts and a point. So I'm going to add another part here, x minus r, in addition to my x minus p and x minus q. So we're going to plug in the 3 x-intercept values. We're going to plug in our additional point xy, solve for a, and rewrite. So here's our first one. So negative 4 could be P, positive 1 could be Q, and positive 3 could be R. And then my other point is 0, negative 6. So using A times x minus P, x minus Q, x minus R, we're going to plug in negative 6 for Y, leave that A. We're going to plug in 0 for each of these x's, so it's 0 minus negative 4, so I'm going to change that to plus, 0 minus 1, and 0 minus 3. So that's going to be A times 4 times negative 1 times negative 3, so that's a positive 12. So divide by 12, sorry, we get negative 1/2. So that means my final answer would be y equals negative 1/2, and then x plus 4, x minus 1, and x minus 3. All right, so you're going to try the next one. Instead of a graph, it just lists the points. So be careful. We know that anything that's going to be considered an x-intercept is the number then comma 0. So that's an x-intercept, that's an x-intercept, and that's an x-intercept. The other point is just our xy. So go ahead, pause it, and when you're ready, hit play to see the answer. All right, so this one would be y equals -2 times x plus 1 times x minus 2 times x minus 3. Now we'll talk about writing the equation of a quadratic using 3 points. So we're going to set it up using x squared a plus xb plus c, and you'll notice that's very similar to y equals ax squared plus bx plus c. I just switched them around so it looks more natural because a, b, and c are now my variables, and I'm substituting in x and y. So we're going to make 3 different equations, one for each ordered pair of x, y. We're going to create the augmented matrix for that system and solve by finding reduced row echelon form, and then we get to rewrite our final equation with the a, b, and c values we found with my reduced row echelon form. So here's our example. NASA can create a weightless environment by flying a plane in parabolic paths. The table shows heights h in feet of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. We first want to write and evaluate a function to approximate the height at which this occurs. So we're going to write the function, and then we're going to plug in 20.8 for the time, which is our x value. So I'm going to pick 3 points here. I could pick any 3. I'm actually going to pick 3 that have nicer x values. It doesn't matter which 3 I choose. So I'm using first 10, 26,900. And remember we said we're going to use y equals, or actually I put the y at the end. Let's flip that around. X squared a plus xb plus c equals y. So the x value is 10. So we're going to start with 10 squared times a plus 10 times b plus c equals the y value of 26,900. My next point was 20, 30,600. So that's going to be 20 squared a plus 20b plus c equals 30,600. And then my last point was the 30, 32,100. Let's switch it to this. So that's going to be 30 squared a plus 30b plus c equals 32,100. So each of these, I would rather have the number there. Instead of 10 squared, I'd rather have 100. So let's go back and change all those. So instead of 30 squared, I'd have 900. Instead of 20 squared, I would have 400. And instead of 10 squared, we would have 100. Come on. Okay. So these are the 3 equations I'm going to use, and I'm going to create an augmented matrix out of these. So that's 110, 1, and then 26,900, and 421, and then 30,600, and then 931, and 32,100. So that is my augmented matrix. So what I'm going to do is I'm going to go over to desmos.com/matrix. I'm going to type this matrix in. So we're going to make a 3 by 4, and let's type that all in. So that was 100, 10, 1, 26, 9. We had 421. We had 931. All right, so there's our matrix. And remember, reduced row echelon form is the RREF. This was called matrix A. So here are my 3 values, -11, 700, and 21,000. So that means when I write my new equation, this is the A value, this is the B value, and this is the C value. So we just found out that A was -11, B was 700, and C was 21,000, which means my answer is going to be y equals negative 11x squared plus 700x plus 21,000. Right, we plug it right back into the quadratic form with A, B, and C. You go ahead and try this one, pause it, and when you're ready, you can check your answer. All right, here's our answer. I noticed on the last one I forgot to do the rest of the problem, but we did the rest here. We found the equation and find the height of the model airplane after 6.5 seconds. So we would plug in x is 6.5 and get about 4 feet because it was 3.975. If I go back to that problem before, they wanted to know after 20.8 seconds, so that means I'd be plugging in 20.8 to this equation. So that would be y equals negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000, and we would get our answer. Right? Sorry, we forgot to do that. All right, the last thing we're going to talk about is writing a cubic equation using 4 points. So it's very similar to how we just did the quadratics, except we need 4 equations instead of 3. And it's going to be x cubed times a plus x squared times b plus x times c plus b. So we're just adding another variable and everything kind of got pushed back one. All right, so here's some points. So if I chose to do 1, 2, 3, and 4, so that's 1 to the third a plus 1 squared b plus 1c plus d equals 1. Now we'll go to 2. 2 to the third a plus 2 squared b plus 2c plus d equals 4. 3 to the third a plus 3 squared b plus 3c plus d equals 20. And one more equation, equals 10. I jumped ahead to the next equation. Here we go. 4 to the third a plus 4 squared b plus 4c plus d equals 20. So you can either rewrite your equations by actually doing this math, or you can go straight to putting the correct numbers into the matrix, whatever you're more comfortable doing. So I'm actually going to go straight to the matrix right now. So 1 to the third is 1, 1 squared is 1, 1 is 1, 1, 1, nice first row. 2 to the third is 8, 2 squared is 4, 2 to the first is 2, 1, 4. 3 cubed is 27, 3 squared is 9, then 3, 1, 10. And 4 to the third is 64, 4 squared is 16, 4, 1, 20. So we're going to go ahead and take this matrix equation, or matrix, go back here, so let me clear out. So now we're going to have a, instead of 3 by 4, 4 by 5. So let's type this all in. 4, 2, 4. Oops. All right, and let's do our reduced row echelon form. Nasty numbers, let's turn them into fractions. A little nicer. We have 1/6, 1/2, 1/3, and 0 for D. All right, so let's write these out. So we had A was 1/6, B was 1/2, C was 1/3, and D was 0. So that's going to be y equals 1/6 x cubed plus 1/2 x squared plus 1/3 x. And I can write plus 0, but it's not necessary. So that's our equation. All right, so you're going to try the last one, pause, and then when you're ready, play to check your answer. Alrighty, so there's our final answer. Y equals negative x cubed plus 4x squared minus 3x minus 4. And that is day 1 of modeling with polynomials.